Let's take the ideas from the previous video and see if we can put them all together into a big polynomial problem. So we're going to try to find the antiderivative of this polynomial. Now, you'll quickly discover that you can shortcut some of what I'm about to do, but let me go through and show you how the different rules work and how we can break this down into smaller pieces. So the first thing we can do is use the sum and difference rules to say that this is the antiderivative of x to the third dx minus the antiderivative of 4x squared dx plus the antiderivative of 7x dx minus the antiderivative of 5 dx. So we can use the sum and difference rules to break this up into a term-by-term antidifferentiation process. Then we can deal with any constant multiples and pull them outside of that antiderivative symbol. So we'll have the antiderivative of x to the third dx minus 4 times the antiderivative of x squared dx plus 7 times the antiderivative of x dx minus 5 times the antiderivative of just dx, or if you prefer, sometimes it's easier to write this as 1 dx. So now we can go through and apply power rules essentially to all of these different pieces here. So we're going to end up with x to the fourth over 4 plus c, but I'm going to wait with the plus c until the very end. I'm going to have minus 4 times, this is going to be x to the third over 3 plus c, but again we'll wait till the end, plus 7 times x squared over 2, again we would pick up a plus c, but I'm waiting, and then finally minus 5 times x. Then I'll add on the plus c. Even though each one of those pieces all get a plus c or a constant, and those are probably all different constants, all those constants will add up into a single constant. So typically when we do our integration work, our antidifferentiation work, we'll be a little loose with how we deal with the constant of integration. We only want to end up with one, and because we can add up all the little ones along the way to get that big one, we'll just kind of do it that way and forget about it at the intermediate steps. I can clean up this final answer here a little bit. I'm going to write it as 1/4 x to the fourth minus 4/3 x to the third plus 7/2 x squared minus 5x plus c, some constant of integration. Take the derivative of this final expression and you should end up back at x to the third minus 4x squared plus 7x minus 5.